Mine was in an first-year engineering course when I was teaching statics, so it's a first-year, first semester course, and the first engineering course that students take. So they take, a lot of other math and science courses, but this is the first one that really kind of integrates and starts to look at applied science for engineering. And so the question that I was interested in was how the students were making sense of these two-dimensional diagrams in their book, which are actually representing three-dimensional structures, and some of them I noticed were having trouble kind of interpreting these two-dimensional diagrams. So that was the genesis of the project, noticing that some students were struggling with this particular skill in my class. When I originally applied to the program, I proposed a controlled experimental kind of a study because coming from engineering, that's what I knew. And I actually knew when I wrote that proposal that I wasn't going to be able to do it because, the class size was about 20. There was no way I was going to be able to control and have enough numbers to have any statistical significance whatsoever, but I proposed that anyway because I didn't know what else to write. And by the time we finished our first retreat, which is focused on developing a question, I had a brand new question, so that was really great. So really, what I decided I wanted to do was just understand the students' process as they were starting to work with these diagrams and interpret them. There's actually lots of literature that shows just experience in spatial visualization helps improve the skill. So I wasn't really interested in that anymore after I'd done my literature review. I was really just interested in what are the students getting stuck in at the beginning of the first semester so that I can help them with it. So I had students do think-aloud interviews where they were given a problem similar to a textbook type of a problem and were just told to talk out loud as they worked through this problem. And what was most surprising for me, actually very disappointing at first, was that they didn't actually follow the instructions when they did their think-alouds, or they didn't follow them as far as I interpreted them. So when I originally listened to them after the end of the course, I thought, oh, well, I'm going to have to start all over again. I have to throw this out because they didn't do what they were supposed to do. Because, of course, coming from an experimental paradigm, when something unexpected happens, then you throw it out and you start again. So I gradually came around to this idea of qualitative research and, themes emerging and the data taking you on a journey and all these new ideas and concepts for me, but really discovered how valuable it was because as I listened to the students, I realized they weren't taking into account the context of the problem. Like if it was a diagram of a tower with some guy wires supporting it, they weren't even realizing that the guy wires, they were supposed to talk about the location of a certain point, and they couldn't recognize that it was on the ground. So they weren't using the context of the problem to help. They also tried to calculate things when there wasn't necessarily enough information in the given problem to actually calculate anything. It was more of a conceptual problem, but they tried to write equations and solve when they couldn't solve. So when I realized what they were doing, I went back into the literature and found all kinds of stuff, mostly from physics, that says, students, just because they can calculate things, they actually don't necessarily have any conceptual understanding. I also found a lot on the novice expert, the expert blind spot. So because we're so advanced in our understanding and we do things automatically, sometimes we don't even realize the things that our students are struggling with. So I found the value of listening to the students as they were working through the problem very valuable and very informative. And actually, once I realized some of the mistakes they were making, so for example, things that were behind the plane of the page, they also had trouble kind of identifying positions and distances. And so I also triangulated what I found in those think-aloud interviews with some of their assignment work over the course of the semester and noticed the same mistakes, the same themes happening in those assignments, but I never would have actually noticed that from the assignments without having had listened to the think-alouds first. So again, very valuable, really just opened my eyes in terms of the assumptions that I make in terms of what my students are doing, and open my eyes to the value of just listening to them talking as they're working through problems. So try to provide more space for that to happen in my classes too.